A stone is dropped from the edge of a roof, hits the ground with a velocity negative 200 feet per second. How high is the roof? Okay, so let's lay out the relations. We know that S, which is position, well, yeah, let's just write it that way. That's position. I don't know why we use S for that, but we do. V is velocity or speed, and A is acceleration. And the relationships here, if you take the derivative of speed, position, you get velocity. If you take the derivative velocity, you get acceleration. And then backwards, therefore, the antiderivative of acceleration will go back to velocity, and the antiderivative of velocity is back to position. Okay. So with that in mind, they're starting us out with this fact here, which is the acceleration of Earth's gravity. So that's acceleration. The Earth accelerates everything. It's negative because it's downward. The Earth pulls us downward at negative 32 feet per second squared. So we want to go from that, and we're going to walk back to velocity, and that's going to be the antiderivative. And so that'll be minus 32t plus constant 1. Right? Because if you took the derivative of minus 32t, go to minus 32, the constant would be 0. So there's the antiderivative, okay? And now we're going to use the information that they give us up here. The stone is dropped from the edge of a roof. That means the velocity is 0 at time 0, right? Because at the start, so when time is 0, they drop it, meaning they don't throw it up or throw it down. They don't give it a positive velocity up, and they don't give the rock, the stone, an initial velocity down, negative. They just drop it. So when you drop something, the minute you let go of it for just a split second, it is hanging with 0 velocity. It's not going down, it's not going up, and then gravity starts pulling on it, and of course it goes down. Well, so that means right at the start, at time 0, the velocity is 0. So that means if I plug in, so the velocity will be 0 when the time is 0. So with that in mind, we can see that constant is just 0, right? Constant 1 is just 0. So now we have the velocity equation, oops, which is minus 32t, since we now know C1 is 0. So it's just minus 32t. So we got the velocity equation. Now we can take one more antiderivative step and get to the um, position equation. Position, be the antiderivative again. That'll be minus 32. We're going to take that t, which is 1 part. We're going to add 1. That'll be squared over 2, plus constant 2. And so that means the position equation is minus 16t squared plus constant 2. Now, what can we do here? Well, we know that what do we know? We know that when the stone hits the ground, its velocity is negative 200. So I can take that velocity equation over here. Velocity is minus 32t. And the velocity is negative 200, right? As I said, negative 200 seconds when it hits the ground. So I can plug in negative 200 and I can solve for the time when it hits the ground. Divide by minus 32. Boom. T equals. You could type it into decimals. It'll be 6.25. Let me show you. And it's coming up. Wait for it. Okay. Guess I'm gonna have to redo it. So what is it? It's 200 over 32. So I'll go 200 over 32. 6.25. There we go. So that means 6.25 is the time when the stone hits the ground. How do I know that? Because I plugged in the velocity at negative 200 when it hits the ground. Solve for time, so it hits the ground at 6.25 seconds. Okay. So what do we know about that? Well, now we know that if we take that time, plug it in here, that the height will be zero, right? Because when it hits the ground, the height is zero, the position. Height equals zero at t equals 6.25 seconds, right? Because that's when it hits the ground. So you plug in that for time. And at that moment, its height, its position is zero when it hits the ground. So now you can use Desmos, minus 16 times 6.25 squared. So minus 16 times, I use the answer squared. And I'm getting negative 625. So that's negative 625 plus C2. Just bounce that to the other side. So C2 is positive 625. So now we have the position equation. S is negative 16t squared plus 625 since we know C2 is 625, right? Right there. Okay, now we have the position equation. All right. Last thing, what do we want to know? We want to know the height of the roof. Well, how do you find the height of the roof? Well, um, when t is zero, the stone is on the roof, right? So if I plug in zero for t, the position I get, this is be gone, 625, that must be the height of the roof because that's where the stone started, right? At time zero, the position is the roof. And there it is, 625. That's how tall the roof is. And so there we go.